No.
Call is now being recorded.
Second, please. Hello, Shazib. How are you? I wonder.
Sir,
Yes.
the topical pass paper that you shared with us, when I tried opening it, it says that the file is too big to preview or download.
Yeah, you have to download that file actually.
Sir,
So
but I can't because it says that the file is too large.
you should click the three dots next to it and then just download that. Okay. Is it clear? So you have to physically download that file in your PC or whatever you're using. Okay.
Okay, sir, I'll check again.
Yeah, it doesn't open like that. Asma, this is the first time you're late. Why? Why is that, Asma? Okay. So we're gonna basically learn the features of this graph. You didn't get the link? Asma, we have the same link every day. Okay. Anyway, so I'm gonna now go to the next. We're gonna basically learn three type of questions in this, and then let's see. Okay. So now check this out, kids. So question type one question. One by one, I'm gonna teach you how to solve these questions, and then obviously you guys can learn this yourself. It's not that far. This chapter is not that easy hard. So it says a metal wire of cross section area, cross sectional area, 0.20 millimeter square, hangs vertically from a fixed point. Then says a load of 84 newtons is then attached to the lower end of wire. The wire obeys Hooke's law um, and increases in length by 0.30%. So then it says what is the Young's modulus of metal wire? This is the question. All right. Wait a second. I'll be back in 1 second. All right, kids. Just I'm sorry about that. Just internet was causing some interruption. Asma, wait a second. So you're saying to me it's not been renamed? How's that possible? Let me check now. Oh no 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 no. Yes, physics. Asma, they are renamed. You see, you see AS level lecture two. It's been renamed. Why do you say it's not? Asma, you need to basically go to the folder actually this time. Okay, go to the folder here. Now we have made folders of this. You can click and then access the file that you want to see. Okay, Asma. Anybody else wants to go through that? Anyway, so where were we? Okay, so we were doing this question. Now, please understand this. Whenever this type of question comes, this is a very fairly simple one. Just try to write down what's available to you. For example, the first one is like cross-sectional area. So I'm going to write area is 0.20 millimeter square. Then they have given to you a force, which is 84 newtons. And then they have said the wire who base hooks increases the length. Now, this percentage is basically strain because only a percentage in change in length can be given as strain. So, you guys need to remember that. What do you need? You need Young's modulus. We already know that Young's modulus is given by stress over strain. But again, you can basically find the stress. We don't have the stress. So stress is force over area. The force is 84, but the area is given in millimeter square. So how do we change that? Please check this out. 1 millimeter is 10 raised to power minus 3 meters. All right, like that. And then if you square it up to find millimeter square, so it's going to be 1 millimeter square equals to 10 raised to power minus 6 meter square. So you can just put 0.20 and replace this millimeter square with 10 raised to power minus 6. So this will automatically convert it into meters. Now what you're going to do is you can simply find this. This will come out as 4.2 times 10 raised to power 8 pascals. So this is the stress. And then you got to find the Young's modulus. Young's modulus will be 4.2 times 10 raised to power 8 divided by strain is in percentage. So you can basically divide by 100 to convert into a fraction or decimal. So it's going to be 0030. So the Young modulus should come out as 1.4 times 10 raised to 11 pascals. Please look at this question. Let me know if you have a question here.
Oh, sir.
All good? Everybody understands this?
Yes.
Now we have another sort of question, which is
Yes.
basically yes, yes, please.
So what's in the denominator?
Strain. You mean here?
Yes.
This is strain because strain was in percentage, so I basically divided it by 100.
Yes.
So it became 0.0030. You get it? Like that.
Yes, sir.
Now, another type of question that they're going to give you, this is a ratio type of question. Now, I just want to tell you that this sort of question is, um, then this sort of question is basically very common. So let's suppose they have given you a object like this. they have shown you two different materials, one a bit thicker and one a bit thinner. Okay, I have to do it with my hand. Wait a second. Okay. Now they say that there is a load that is hanging through these two materials. This wire, they say this is copper. This is steel, and this is the weight. All right, so this is something. Now they've said that Young's modulus of steel is twice that of copper. So this is the first point. Then they've said that both wires have same length of 50 centimeter. Then they say the diameter of copper is 2.0 millimeter and the diameter of steel is 1.0 millimeter, like that. So they say if they obey Hooke's law, determine the ratio extension of steel over extension of copper. So this is basically the question. All right, so we got to determine the ratio like that. Now there are a couple of ways to do this, and we're gonna basically test them out in a bit. So first of all, I'm gonna do with the most effective method in my opinion. Basically, I know Young's modulus formula is given by FL over AX. We've learned it in the previous lesson. So I'm just following the method one, all right? If you like it, you can follow this. But if you don't, I'm going to give you the other method for this as well. Then I'm going to give you a question. So I'm going to write, what do I need? I need force. I need length for this formula. I need area. And I need to find extension. So I need Young's modulus as well. Also, I have diameter. I have two wires. I have basically steel and I have copper. So I'm going to gather the information, write it down in the table. So it will take only like 1 minute of your time, but it will help you not make a mistake. Now, obviously, they are connected with the weight, and obviously, there's in series. We've learned that in series, the force is same in both of them, which means both will face the same force, which is weight. They have the same length, 50 centimeter. The other one also has 50 centimeter. Now, we do not know the area, but we do know that the Young's modulus of steel and modulus of copper. Do you guys get it? Please let me know if this is confusing for you. We also the diameter of copper.
Sir, your voice is cutting.
Sorry.
Sir, your voice is cutting.
Okay. Wait a second. Let me switch the internet. Just give me 1 second. I don't know where my phone, the other phone is. Wait a second. Where did I put it? fair. That's not fair. Wait a second, please. Okay, that's bad. I think I kept my phone and forgot about it somewhere. Okay, sure. Uh, is it any better? Or it's
Yes, sir,
staying?
it is. Okay. Yes, yes.
All right. Now you see what I was saying. Young modulus of steel is twice of copper, so I've written it like that. And then basically you need to worry about the diameter. Okay. Now you
Yes,
see the diameter of copper is 2, diameter of steel is 1. Can I say the diameter of, if copper is the diameter d, then steel has, sorry, if the diameter of steel is d, then copper has 2 times the diameter of that. Do you guys agree?
yes,
Okay. Now I need to work out a small relationship. You see, I'm going to write it here. Area is basically proportional to diameter square. You guys agree? Because it's radius square, so
yes,
if something has twice the diameter, what would the area be? Can somebody please tell me that? If something has twice the relationship is a square relationship. If you have twice the
four
diameter,
times,
area should be 4
four
times. Do you
times.
guys agree? Yeah. So it means the area of copper is 4 times this, and the area of steel compared to steel. Get it?
Yes,
Once you have filled the table, just we need extension of this, right? So we're gonna write what do we need? Extension of steel, which is given by, according to the formula, force in steel times length of steel divided by area of steel and Young modulus of steel. An extension of copper is force in copper, length of copper, area of copper, and Young modulus of copper. Get it?
yes,
What do you need to do? You need to find the ratio. So we're going to divide this. We're going to divide the two equations together to find the ratio. Now, see, extension of steel over extension of copper is going to be, now normally what I do is when I write these formulas, because they can be very complicated, I put this sign instead of the normal, slash divide. Why I do this? Because this sign, basically when you remove this sign, you would notice that actually when I remove this, it is going to take the reciprocal of the other term. You guys agree?
yes,
Now simply put all the values that we've gathered in the table. So you see, okay. So all the values that we've gathered in the table is forces W times length is 50 divided by, so I'm putting steel things, okay? Area is A and Young modulus is 2E multiplied by, multiplied by, and then the other one is area of copper is 4 times A. The Young modulus of copper is E. The force of copper is W, and the length of copper is 50. Now it is very easy for you to cancel these things together. So let's check. W gets cancelled with W, 50 gets cancelled with 50, E gets cancelled by E, A gets cancelled by A. What are you left with? You're left with 4 divided by 2. So the answer will be 2. Do you guys understand that?
Yes.
Please write this down. Abdullah, about you, Shazib, Furqan. Yes. And Fatima, what about you? And Zirwa, Imal, Asma, everything is clear.
Yes, sir.
Sir,
Now,
what's the difference between length and diameter?
what is the
Difference between length and diameter?
basically when you make a wire, right? If it's a circular cross section, it will have a diameter like this. Let me show you. It will have diameter like this, right? And length like this. That's the
Oh,
difference.
okay. Thank you.
Understood?
Yes. Thank you.
Now we're gonna basically move to the other method, which is basically sort of quicker, but it has also a high chance of getting it wrong. For example, if you look at this, what do we need? We know the formula of extension of steel is force of steel, length of steel, and area of steel, and Young modulus of steel. You guys agree?
Yes.
Okay. Now see, the weight force is same, so we're going to ignore that completely. Um, the length, so we can also length is like the same, but the area of steel was basically
Sir,
A.
are you writing something because I cannot see anything?
No, I'm not writing. I'm just telling you.
Okay.
Okay. Area of area of steel is A, but the Young modulus of steel is 2 times. You see, they have inverse relationship. You guys agree?
Yes.
If steel has an inverse relationship of this, if you multiply 2 times, what will happen? It will become half because they're inversely proportional. Do you guys get it?
Yes.
Now for the other one, copper. Force of copper is the same, length of copper is the same, area is 4 times area. So what can we do? We have to basically multiply 1 by 4 here. So because 4 is like divided on the other side, it is inversely proportional. If we multiply area by 4, the extension will be quarter. Is it clear?
Yes.
And Young modulus is this. Now what do we need to do? We need to do extension of steel over extension of copper. So we're going to put the values. Half and then divided by 1 by 4 because a copper had this term with it, that had this term with it. So 2 will come down, 4 will go up, so it will be 4 by 2, and this will be just like this. So it is very simple and small, but then you need to be very aware of it that you're not missing any term or its ratio. Is it clear? So it's really up to you which you
Yes.
want to follow. But it is very, I mean, it would be good if you draw this table in any case, because table helps you analyze stuff better like that. Everyone gets it?
Sir, the
Yes.
ratio between the extension of steel and copper is 2, right?
Extension of key, steel and copper. Yes, it is 2 because it's 4 over 2. That's why. Understood? Okay. Now I will give you, you can write this method. Both methods are equally good. Whatever you like, you can do it. But I'm gonna basically going to give you one question just to see if you guys understand everything. So let's do it right now. Shazib, are you there? And Furqan, Abdullah, about you. What are you doing? You can copy this, please, because I got to go to the next page then. Give you a question. All right. Done. Should I go forward now?
Yes.
Okay, kids. Now a question for you. It is a sort of same difficulty, but a little bit different. So now let's do a question here. In this question, they have shown you a bar like that, like this. So you have force of tension in this bar, like that. Now they say that diameter of wide portion is twice the diameter of narrow portion. You guys can see that as well from the diagram. Okay. Force T acts on both cross sections. Find the ratio stress in the wide portion divided by the stress in the narrow portion. All right, can you guys please try this? You have no more than that.
So I got 1 by 4. Sir?
All right.
So I got 1/4.
Sorry? 1/4. Yeah, this is correct. 3.25 is the ratio.
So you're lagging.
So we should have that. Okay. Now let me tell you. I don't know why this is. Let me say. Okay. Just this, okay? All you need to do is you need to write, because you need stress, so you just need force and area. Now, if I were you, I would write force, I would write area, and I have diameter as well, so I'll write diameter. And then I'm going to write what two things I'm looking for. I'm looking for wide, and I'm going to look for narrow. Now I know the diameter of wide is two times the diameter of narrow. So that means that the area of wide will be four times because area is square of whatever the diameter is. Do you guys understand that? Imal, is it okay now? My voice?
Yes, sir.
Okay. And the force
Area is square of diameter, or diameter is the square of area?
diameter square is the area. Do you get it?
Okay. Thank you.
Basically, area is of any circular thing is pi r square. So basically, radius is diameter by 2. When you put it inside, so area becomes pi d by 2 whole square. So area will be pi d square by 2. This is the actual formula, but we're not interested in finding the actual value of area. What we need to understand this, these two quantities are constant, so area is proportional to diameter square. So if you increase diameter by 2, it means the area increases by 4. If you increase diameter by 3, it means area increases by 9. Do you get it? It's square of everything.
Yes.
Okay, and the force is the same. Okay, now we need to just write the two equations. What are two equations? The wide stress would be the force, which is the tension, divided by area is 4a, and stress in narrow would be the tension, and area is a. Just divide these two together. So it's going to be stress in wide or stress in narrow equals to tension over 4a divided by tension over a. Then when you remove the multiplication, you remove the sign, divide sign. Basically, you can take the reciprocal other side. Now you can cancel area with area, tension with tension. So it will leave you with just 4, which is 0.25. Do you guys get it?
Yes.
Okay. Any questions now?
No, sir.
Okay, good. Now you can basically copy these. Those who got it wrong. Shazib, what was your answer? And Furqan, Abdullah, Zirwa, Fatima, please tell me your answers that you originally got. All right, kids. So I hope that's clear to you. And now let's look at one more thing before we leave. Okay. Now there is a sort of relationship that we need to prove. Okay. It's called the relationship between um, Young's modulus and K. All right, spring constant. That's right, spring constant. So this is a derivation that can come for 2 marks. So just look at that. So we know that force is equal to kx, and spring constant is defined by force over extension. So most of you know this already. I mean, everybody should. And Young's modulus is basically force times length over area times extension. You guys know that as well. If I just write Young's modulus as f over x times length over area, would you guys mind?
No.
Then this would be k times length over area. Do you guys get it?
Yes.
If that is the case, then, so can I say that basically length over area is just constant things? So Young's modulus is proportional to the spring constant, which also means then that Young's modulus also represents stiffness of a material because it is proportional to K. Do you guys get it?
Yes.
So you can write that as well, please. So this is just very small derivation, 2 marks things, and then that's all. So we basically covered the thing here, and yeah, it's good. Now we short of just one small class, and then we'll be able to finish this chapter. Now, thank God, we'll only left with I think waves, electricity, and nuclear physics. It's only three chapters. I think we'll be able to finish them very soon as well. All right. So if you guys have written this, you guys can go then, and I will see you tomorrow. Have a nice day then.
Thank you,
Bye.
sir. Love this.
Thank you, Salafit.
Love, please.